So in this video, we're going to see chapter number 9, areas of parallelograms and triangles. We're going to see an important proof in this video. So let's see what the proof reads. First, let's read the statement. Two triangles on the same base or equal bases and between the same parallels are equal in area. So let's try to visualize what the proof says. Yes. So we have this two parallel lines. Okay, these are two parallel lines. Now, and we have two triangles on the same base. So AB is our same base. Okay, let me use a highlighter. So AB is our same base here, and we have two triangles on the same base and between same parallel line. So this is one parallel line, this is one parallel line. Now these two triangles ACB and ADB are equal in area. That is what the theorem says, and that is what we are going to prove. So first let us write down to prove okay, area of triangle ACB is equal to area of triangle ADB. That is what we have to prove. Okay, so now let's try to zoom in and see how that can be done. So let's come to this diagram. Let's try to zoom in here. Now in order to prove this theorem, first of all, let's reduce this. We don't need this much of parallel lines. Okay. Yeah, maybe a little. Yeah. So okay. So in order to prove this theorem, we are going to use the previous two theorems that we have seen with respect to parallelograms and triangle between the same parallels and same base. Okay. So first we are going to do some construction. So point number one. So I'm just going to write it here. Point number one. Construct. Okay. Construct from vertex B a line, okay, a line parallel to AC. Okay, so I'm going to use a highlighter. This is my vertex B. This is from vertex B. I'm going to construct a line parallel to this AC. Okay, parallel to the side AC. So let's do it. Yes. So from vertex B, I'm going to draw a line parallel to AC. It will look somewhat like this. Now let's call this point as P. Let's call this point as P. Okay. Okay. Let's call this point as P. Okay. Now focus on this quadrilateral. Okay. A, C, P, and B. Okay. I'm going to highlight it using the green. This is the quadrilateral that we have to focus on. So now in this quadrilateral, we have AC as parallel to BP because that's how we constructed, and we have we have CP as parallel to AB because these were the two original parallel lines. So thus in this quadrilateral, we have opposite sides as parallel to each other, and in a quadrilateral, if opposite sides are parallel to each other, the quadrilateral is a parallelogram. So that's an important observation we have here. So I'm just going to mention here point number 2, that ABPC is a parallelogram. That is very important. Is a parallelogram. Okay. Now focus on this parallelogram Focus on this parallelogram ABCPC and this triangle ACB. Both of them have the same base AB and they are between the same two parallel lines. Okay, which means the area of ACB will be half the area of this parallelogram. Okay, why? Because that is the previous theorem we have seen, that this triangle will always have the area half equal to the parallelogram with the same base AB. Okay, so that is the third point that I'm going to note it down. So triangle A, so area, okay. Uh, so area of triangle ABC is going to be equal to half the area of, so I'm going to just say area of parallelogram ABPC. Okay. Now this completes step 1, that we have shown that this area of triangle is half of its parallelogram. Now let's remove the highlighted things. So this is gone. Okay. Now in step 2, now let's do one thing. We'll create a copy of this so that it's easy to discuss. So Okay. Oh God. So we want to create a copy of this. Okay. Oh no. Why is it not creating a copy? Copy. And we're going to paste it here. Paste. Okay. Now, so we for this triangle ACB, we created a parallelogram. Okay, and we said that the area of that ACB is half of the parallelogram. Now, for this orange triangle ADB, we are also going to construct a parallelogram. So once again, the same process. From vertex B, we are going to construct a line which is parallel to the side AD. So what we can do is we can in fact get rid of this in order to understand it clearly. Let's get rid of the blue lines. Let's zoom in. Yes, so the confusion is less. Yes. Okay, so we have our original triangle ADB. ADB is our original triangle. From this, yes, ADB is our original triangle, and we have constructed from vertex B a line which is parallel to the side AD, and let's call this point as Q. Okay, so let that be my first point, point number 1. So construct from vertex B, okay, from vertex B a line parallel to the side AD. Okay, parallel to the side AD. Now once again I'm going to use a highlighter. Note that this becomes a parallelogram ADQB. This is a parallelogram with the base AB. So AB is the base, and for okay, and for this triangle ADB, the base is same AB, and thus area of triangle ADB will be half of the parallelogram. Okay, so again I'm going to note down it's the same process that we did for the previous this triangle. Okay, we did the same thing for this triangle for this triangle ACB, same process. So let's note down this key information, that area, okay, so area of triangle ADB is also equal to half the area of parallelogram ABQD. Okay, ABQD. So now let's highlight this important thing. We have area of this triangle equal to half of one parallelogram. Okay, and we have area of this triangle also half of its another parallelogram. However, what is the common thing among these two parallelograms? Okay, so this parallelogram is between the same parallel lines and same base AB, and this parallelogram, let me use a highlighter. Okay, this parallelogram is also between the same two parallel lines and the same common base AB. Okay, so okay, so both these parallelograms ABPC and ABQD are between the same base and same parallel lines, which means their area will be equal to each other. So that is my next point which I'm going to note down. So let's use this space here. Okay, let's draw a straight line. Okay, but so I just want this in the frame. Okay, but okay, area of parallelogram ABPC, okay, this parallelogram ABPC is equal to this parallelogram ABQD. Okay, so is equal to area of parallelogram ABQD. Why? Because those two are the parallelograms, once again repeating, emphasizing, because these two are the parallelograms between the same two parallel lines and same base AB, That's the theorem that we have proved in the previous videos, that if there are two parallelograms with the same base and between the same parallel lines, then their areas are equal to each other. So if we have this information that area of ABPC is equal to ABQD, so ABPC is equal to ABQD, then it follows that area of ABC triangle will be equal to area of triangle ADB. Thus, and I'm going to write that point here, thus we can say that area of triangle ABC, okay, is equal to area of triangle ADB, and that is what we wanted to prove, that ABC is equal to ADB. Let's come back to our original. Yes, this is what we wanted to prove, that area of triangle ACB is equal to area of triangle ADB. So in this diagram, let me just remove the highlighted things so that it's a bit clear. Yes. So and also let's remove this. This didn't exist before. And this also didn't exist before. Okay. So original diagram was this, where we had two parallel lines and we had two triangles which are between the same parallel lines with the common base. And all we wanted to prove was that their areas will be equal. And that is what we have proved. This is an important theorem. We are going to use this theorem to solve a lot of exercises in our unsolved problems. That's it.